Hi all. Today we will be discussing system testing, an important phase in software testing where the complete integrated system is tested to verify that it meets all specified requirements. What exactly is system testing? Simply put, it's a level of software testing where the complete and fully integrated software system is tested as a whole. The goal is to verify that the entire system meets all of its specified requirements. There are a few key points to remember. It validates both functional and non-functional requirements. Functional is what it does, and non-functional is how well it does it. It's conducted after integration testing. This means we are not checking if two pieces of code talk to each other. We assume they do. The environment for this testing simulates production conditions, meaning it looks and feels like the final live system. Let's see some simple examples. Online banking system. Integration testing might check if the login module successfully connects with the balance module. System testing, however, checks the complete end-to-end flow. Login, write, then login, view balance, then again transfer funds, followed by logout. So we are testing the user's entire journey, ensuring the system behaves correctly in real-world conditions. System testing has four main objectives: validation, error detection, performance check, and security check. The primary goal is ensuring the system meets the core business and user requirements. Does the application actually solve the problem it was built for? While other testing phases look for errors, system testing is crucial for finding defects missed during earlier testing stages, often related to how different components interact. Performance check is it's nothing but the object. Its objective verifies the response time, stability, and resource usage. If 1,000 users log in, does the site crash? Then security check. Finally, we need to ensure data confidentiality and access control. Can a non-administrator access an admin-only feature? System testing checks this from an external user-like perspective. System testing is not just another step, it's extremely important because it's the last testing phase before deployment. This is your final quality gate. It's the best phase to detect environment and data related issues that simply cannot be found in a developer's isolated environment. Successfully posing system testing builds confidence for user acceptance testing UAT. If the system performs very well, the actual end users are much more likely to accept it. What defines the system testing phase? It has several key features. It's conducted in a protection-like environment, replicating the hardware, software, and network configuration of the final live system. The focus is on end-to-end scenarios, not on individual modules. We are testing the complete user journey. It involves both black box testing without seeing the code, and non-functional testing, speed, security, etc. It can be performed either manually or automated, and it covers both positive and negative test cases. What should happen and what shouldn't happen, it checks that. Then, for example, if you consider for e-commerce system, it's an end-to-end system that will verify the payment gateway integration and should validate the cart updates after payment, and it should ensure email confirmation is correctly sent. System testing is broadly categorized into two main types. As you can see in the uh, Flowchart, functional testing and non-functional testing. Functional testing focuses on what the system does and ensure it meets their explicit requirements. This includes types like smoke, sanity, regression, and usability. Non-functional testing focuses on how well the system performs, covering areas like performance, security, load, and compatibility. Let's look few common functional testing types. Smoke testing. Smoke testing is a quick test to verify the system's basic stability after a new build. A quick example is just checking if the login functionality works. Sanity testing. This is focused check after a specific bug fix. For instance, if you fix a payment issue, you immediately test the checkout process again. Regression testing, the key is to ensure new code hasn't accidentally broken old features. A great example is if you update the user interface, you then check the entire checkout flow to ensure it still works. Usability testing, this measures the ease of use for the end user, such as a test on the clarity of navigation. Non-functional testing is where we prove the system is robust and ready for the real world. Performance testing in this it focuses on speed and responsiveness. A test could be simulating 1,000 users logging in simultaneously. Load testing tests the system's ability to handle the expected loads to determine its capacity limits. This might involve a test of the server load at peak business hours. Stress testing pushes the system beyond its normal operational limits to see how it reacts. For example, observing the system reaction under a failure or overload. Security testing focused on data protection, such as attempting an unauthorized access attempt. Compatibility testing checks functionality across different devices and browsers, ensuring the application works on Chrome, Edge, and mobile devices. System testing is a structured process. Here are the key steps. Requirement analysis. We start by thoroughly understanding all functional and non-functional requirements. Then test planning. We define the scope, allocate resources and tools, and set the schedule. Test case design. This is where we create detailed end-to-end scenario. Environment setup. A dedicated production-like environment is created for testing. Test execution. We run the designed manual or automated test. Defect tracking. Any issues found are logged using tools like ZIRA or Bugzilla. Retesting and regression. Once developers fix a bug, we retest it and run regression to ensure the fix didn't break anything else. Test closure. The phase concludes with the preparation of final reports and metrics. These are the some of the common tools that are used for automation: Selenium and TestNG, defect tracking, Zira and Bugzilla, performance, load runner, and JMeter. Effective system testing relies on well-designed test cases and powerful tools. Here are some real-world test case scenarios. Scenario 1, login with valid credentials. Expected result is user redirected to home page. So it is a positive test. Another scenario, network disconnects during payment. Expected result, error handled gratefully. A negative non-functional test. This one is. To run these tests, we use various tools: automation, Selenium WebDriver for web application automation, API testing. Postman is excellent for testing the interaction between different services. Performance, JMeter or load runner to simulate a large number of users. Cross browser or device browser stack to ensure compatibility across various platforms. For Selenium WebDriver, it is supported for automation of web applications. Postman API testing use. JMeter mainly used for load and performance testing, Browser Stack mainly used for cross-browser and device testing. So let's look at three scenarios that demonstrates the end-to-end nature of system testing. In banking application, a system tester checks if a user can transfer money, view history, and then securely log out. So we are testing the complete transaction chain. On a hotel booking site, the test involves the full user journey. Can the user search hotels, apply filters, view images, book rooms, and successfully get a confirmation? If the answer is yes, the system has passed. In a ride sharing app, the system test follows the entire process. Request a ride, driver accepts, GPS tracks, you pay and you rate. This end-to-end journey is the core of the system testing. System testing is crucial, but it's not always smooth. Some common challenges are incomplete or ambiguous requirements, last minute changes to the system, limited or insufficient test data, tight time considerations. To overcome these, we must follow best practices. Start testing early, don't wait until the last minute. Automate repetitive tests for efficiency. Communicate closely with developers and business teams to resolve issues quickly. Use real world scenarios to simulate actual user behavior. Prioritize testing based on risk. The, ulti- the ultimate goal is not 100% testing, but but to catch the most critical issues before users do. To quickly summarize our session, systems testing validates the entire software system as a single coherent unit. It covers both functional and non-functional aspects of the software. It ensures the software is truly ready for user acceptance testing UAT. Crucially, it is designed to detect integration, performance, and stability.